is pertaining to sensitivity list. Okay, sensitivity list, you know, always at, so in bracket you will write that is sensitivity list. So we'll directly take example. Okay, so problem with incomplete sensitivity list. Incomplete sensitivity list means you are not writing all the variable in the sensitivity list. During that time, what is the problem? Okay, we'll see now. You see this code. Okay, module code 1, output A, input A and B, A or O equal to A and B. Okay, so this is what simple AND gate, right? So whenever there is a change in A or B, this block will execute, right? So here it's not a problem. So but you come to here, they are telling that always at A, O equal to A and B. Okay, now I will tell you. So here what is the problem? Here you have not defined B. Okay, so whenever there is a change in B, this block will not execute, right? So your output will not evaluate. So during that time, what is the problem? This block will not at all execute, right? But it should execute in real hardware, right? Now this is one problem in simulation. Now coming to synthesis, how synthesis will infer. Okay, so first synthesis will check always at A. Okay, so first synthesis tool will see always sensitivity list always at A. So it will see that there is no pos edge, there is no neg edge. So definitely some combination logic will come. Okay, so first thing is synthesis tool has to give you a combination circuit. Okay, then synthesis tool will go and read this comment A and B. After that, synthesis tool will come to know that designer is looking for a AND gate with two inputs A and B and one output, that is O. Okay, so hardware you will get right. Okay, so gate level netlist you will get right. Okay, now if you force A and B to the gate level netlist, you will get right results. Whenever there is a change in B, getting, see, actually what is the problem? See, you see, first you
the change in A, that time we will get the output.
Yeah, during simulation. Okay, simulation you have defined only A in the sensitivity list. So whenever there is a change in A, then only this block will execute. Yes. And output is getting evaluated. Yes. But whenever B is getting changed, so during that time you will not find any change in output, right? Because this block will not at all execute. Yes. Okay, so this is the problem in simulation, right? Now how synthesis tool will work, I am explaining that thing. Always at A, so synthesis tool will come to know, yeah, so designer is looking for some combination circuit because there is no pos edge or neg edge. Yes. If pos edge is there or neg edge is there, means they are looking for some flip flop. Okay, so one thing is clear. Now after that, what sort of hardware synthesis tool is looking for? That is the objective. So synthesis tool will read this statement. Yes. So A and B. So what it will do? It will take an AND gate with two inputs A and B and one output O. So you will get right gate, right? Yes. Right gate level netlist. Now if you are forcing both the values A and B, it will show the changes, right? Even if there is a change in B, it will show the output because that is the real hardware you are getting. Yes. But you are not mimicking that thing here, right? With the change in B, your output is not getting evaluated, right? So mismatches you will find. So actually you see, using synthesis tool directive, synopsis full case. Okay, so this is a directive to synthesis tool. Okay, you see this example. Module code 4A, Y, A, E, N. Okay, output is Y, input is A, input is enable, and they are using this. Okay, so always at A or enable begin, Y equal to 4 tick H0, case enable 1 tick B1. Okay, now you tell me A is how much bit? A is 2 bit, right? So is there any problem here in this case? Any problem in this circuit?
No problem.
No problem. Why?
All the four conditions are exercised.
No, A is 2 bit here.
Yeah, that's what.
Enable is 3. No, you are using the enable.
Oh, and then there is a problem.
Why there is a problem? Because you have not listed down all the combinations. Okay, how there is a problem? Can you justify that thing?
It's as simple like if what happens will if the other combinations of the code will occur.
Suppose 0, 1, 1 will occur. During that time, what will happen?
That's what. No. That is not mentioned.
No, actually there is no problem in this code. I will tell you how. Okay. Actually, what is the problem now? See, you see here. This is 3 bit total. Okay. So they are telling how many combination will come? 8 combination, right? So they have mentioned only 4 combinations. So what about the other 4 combinations? Okay, that is a problem. If those four combination is not there, then what will happen? Usually latch will you will infer a latch. Okay, but here no latch will infer. Why? See, whenever there is a change in A or enable, okay, this block will execute. Okay, you are assigning a y equal to 4 tick as 0. So you are assigning some value to y, right, before itself. Okay, so in this case no latch will come, even if here is no possible combination. Okay, so you first assume that this statement is not there. Fine, this statement is not there for y equal to 4 tick as 0. So if any possible combination will come like 0 1 1, no statement is there, right? So what output you will get? It will maintain the previous value, right? But here what you are doing, at the beginning itself you are assigning the value of y to 4 tick b0, default value. So in this case it will not infer a latch. Okay, in every execution you are assigning the output to some known state, right? So this will not so don't think that always when case in case all the expression you have not mentioned, it will infer a latch. Okay, it's better you, for your own benefit and in order to avoid latch, you define the output to some known state at the beginning of the sensitivity list. Okay, when I explained you FSM, okay, in that case you have seen always at when you are having sensitivity list, below that they are assigning next state to some x state value, default state. Why? Not to model the latches.